All right, we've moved into the last unit here. We're going to go over factoring, a ton of factoring, and then we're going to do some complex number operations in this part. All right, first one, 23a. I'm looking here and I see that I have a GCF. I can take out a 6 when I look at the 12, the 18, and the -6. I look at my x, my lowest exponent is x to the first power. And then for my y, also my lowest exponent is y to the first power. So dividing each of these three by 6xy leaves me 2x squared plus 3xy minus, it looks like that's going to be just -1. Okay, that's it for the first one. Let's go to b. So b is a quadratic trinomial where I'm going to make La Nina over here, so a times c, that adds to b. My a is 1, my c is -35, and my b is -2. So I need two numbers that multiply to give me -35 and add to -2. I'm thinking -7 times 5 would work. Now because a is 1, I can go straight into writing my two factors as x minus 7 and x plus 5. Notice we're only factoring on this page, so there's no equal signs, right? Which means I don't need to worry about solving, so this is my final answer. Okay, letter C. Now, letter C is one of those where I recognize this is a perfect square trinomial. If you do not, that is okay. These numbers are quite high without any GCFs and without a calculator. So just take this one kind of with a grain of salt here. I notice that this right here, the square root of 49x squared is 7x. This one here, the square root of 16 is 4. And then if you did 7x times 4 times 2, right, you would end up getting this 56x. So I know that it's going to be 7x plus 4 squared. All right, first one squared, the last one squared. The middle term is the first times the second term times 2. All right, now if you don't recognize that, that's okay. Use La Nina to help you get that, and the numbers will not be that super high because you don't have a calculator. Okay, letter D, one of our favorites, substitution. So we're going to say W is equal to 3x plus 2 to make this W squared plus 6W plus 8, making La Nina is A times C, that adds to B. So that's 1 times 8, that's 8, that adds to 6. So 4 times 2 is 8. 4 plus 2 is 6. So this factors as W plus 4, W plus 2, but we're not done because I got to put that 3x plus 2 back where it says W. All right, so we finish with 3x plus 6 and 3x plus 4. Now I recognize that 3x plus 6 can still be factored. So if you wanted to, you could take out the 3 and write x plus 2. And then 3x plus 4, that is unnecessary. I would accept that as the answer. Okay, E. All right, this is a special case, but I'm making La Nina because my A is 1 and it is a trinomial. So I'm going to write 1 times 24, which is 24, that adds to -11. So let's see, factors of 24 that add to -11. Not 6, 8 and 3. Took me too long there. Sorry about that. Oh, wait, no, I'm not going to be 8 and 3. Yes, 8 and 3. -8 and -3. All right, those multiply to positive 24 and add to a -11. So we're good there. Now notice we go 4 and then we go 2. So I'm going to write my A minus 8 and my A minus 3 because we have the number in front of A is 1. But I need to account for the fact that this is not A squared, then A, then the constant by putting those squares in, right? And if you ever need to check, you can always FOIL to see if you get back with the original. And neither of those are the difference of two squares, so I'm done factoring in part E. Let's go to part F. All right, this one I don't see a GCF, so I'm going to make La Nina. All right, A times C, that adds to B, so I have 3 times 8, which is 24. B is -14. Okay, factors of 24 that add to -14. I'm thinking -12 and -2. That should work. Now notice the number in front of x squared is not 1, so I will be splitting the middle to use grouping. So 3x squared minus 12x minus 2x plus 8. Let's group. I can take out a 3x. I'm left with x minus 4. Take out a negative 2, left with x minus 4. So my two factors are 3x minus 2, and then bring down 1, x minus 4. Okay, letter G. All right, looks like I do have a GCF of x. So take out a 1x. So 2x cubed plus x squared minus 50x minus 25. And then I'm just going to let that x kind of just come down for the ride. So group the remaining 4. So that's going to be, take out x squared, you're left with 2x plus 1. Take out a minus 25, you're left with 2x plus 1. So my overall, I'm going to write down x squared minus 25. Oh my goodness, that's the difference of two squares. What a day. Bring down that x. So I have x times x minus 5, x plus 5, and then 2x plus 1. That was amazing. Okay, H. This is the difference of two squares, right? I have 16x to the 4th power and 81, which are perfect squares. So that's 4x squared, and then that's 9. So I'm going to write 4x squared minus 9, 4x squared plus 9, and oh, look at that. 4x squared minus 9 can keep going. That's another difference of two squares. So 2x minus 3, 2x plus 3, and then bring down the 4x squared plus 9. All right, last two. Another one where I'm going to make La Nina, and then I have like kind of a special case here. So 1 and 18. I don't have any GCFs here. So factors of 18, add to negative 9. I'm thinking negative 6 and negative 3. Okay, similar to one we did earlier, I'm going to write the x minus 6. I'm going to write the x minus 3 because the number in front of our x to the 6th power is 1. But if I were to FOIL this right now, I'd get x squared, I'd get x to the 1st power. So I need to make these x cubes, right? Because x cubed times x cubed is going to be x to the 6th power, right? When you multiply with the same base, you add the exponents, all right? So neither of those can keep going, so I'm done there. Last one. Don't see a GCF, so I'm going to make La Nina here. A times c that adds to b. 10 times negative 5 is negative 50. This is negative 23. So two numbers that multiply to give me negative 50 and add to negative 23, negative 25 and positive 2. Notice the number in front of your squared term is not 1. So I am going to use split the middle to do grouping. So minus 25x plus 2x minus 5. Let's group. So those first two, I'm going to take out, I'm guessing 5x, which leaves me with 2x minus 5. Then take out a 1, 2x minus 5. So my two factors are 5x plus 1 and 2x minus 5. That is it. Guys, love the factoring. So much fun. Okay, complex numbers time. All right, so in this one, I'm going to do a bunch of operations. Keep in mind, for a lot of these, we're going to end up with something with I squared. I squared is negative 1. You got to memorize that I squared is negative 1. All right, so this one is multiplication. I'm going to FOIL. 3 times 2 is 6. 3 times 4i is 12i. Negative 7i times 2 is negative 14i. Negative 7i times 4i is negative 28i squared. Okay, I'm going to combine the middle two terms to get minus 2i. I'm going to write this as negative 28 times negative 1, which becomes a positive 28. So my answer is going to be 34 minus 2i. Make sure you put it in standard form, right? Real number, and then the imaginary number. Okay, that's important. We will take off for that. Okay, B. This is division, which is really just two instances of multiplication, multiplying by the conjugate of the denominator, which is 3 plus 2i. So I'm going to do two instances of multiplication. So the numerators, 10 minus 7i times 3 plus 2i. So that's going to be 30 plus 20i minus 21i minus 14i squared. So that's going to be 30 minus I, negative 14i squared. Remember, I squared is negative 1. So that's really plus 14. So that's 44 minus I. That's my new numerator. Let's get the new denominator. 3 minus 2i, 3 plus 2i. So I have 9 plus 6i minus 6i minus 4i squared. The middle two pieces cross out. That's on purpose. So 9 minus 4i squared is really 9 plus 4, so my new denominator is 13. So my answer is going to be 44 minus I over 13. Okay, C. C, I'm going to do all this stuff squared. So 3i squared is 9i squared. And then the square root of 5 squared is actually just 5. So this is now 45i squared. And I'm hoping you know that I squared is negative 1. So 45 times negative 1 is negative 45. Okay, another division, which is multiplying by the conjugate of the denominator. Notice you don't change the sign of the first term, just the sign in the middle. So I've got my new numerator to find. Let's do that first. Negative 45 minus 63i plus 55i plus 77i squared. So that's negative 45 minus 8i minus 77. Okay, so minus 8i, so that's what? 80 plus 45 would be 125, take away 3, so that's negative 122 minus 8i. Minus 8i. Let's get that I closer. Okay, that's the new numerator. Let's find the new denominator. Negative 5 minus 7i, so that's going to be 25, and then plus 35i minus 35i. Remember, those are going to cross out to make 0. Then minus 49i squared. All right, so that's 25 plus 49. Yes, so that's going to be 74. All right, and then I'm going to write those in a new fraction. So 74 is on the bottom. Negative 122 minus 8i. And actually, all four of these can be divided by 2. So I'm going to write negative 61 minus 4i over 37. Okay, last one. Oh, 2 more. Yes. All right, so 2 multiplications that we're going to add at the end. So negative 6 times 5, so just FOIL start. It's negative 30 plus 48i minus 20i plus 32i squared plus 4 plus 3i minus 4i minus 3i squared. Whew, it's a lot. Okay, here we go. So I'm going to highlight all my i's. So 48i minus 20i, 3i, negative 4i. Let's see what that is. That is 48 minus 20 is 28. 28 plus 3 is 31. 31 minus 4 is 27. So I got 27i. Then I'm going to have negative 30 plus 4. I'm going to move this actually over here. And then plus 32i squared is minus 32. And then minus 3i squared is plus 3. So what is all that? Negative 30 and negative 32 is negative 62. Negative 62 plus 7 is negative 55 plus 27i. Let's go. All right, last one. Remember to write these in terms of I squared, right? Because you know I squared is negative 1. So I squared to the, I think, 48th power, right? 48 times 2 is 96. But you'd still have 1 left over to get 97. So negative 1 to the 48th power times I. A negative 1 to an even power is a positive 1. So 1 times I gives you just I. All right, we did it, guys. All right, come back. We got one more part to go. Let's go.